Hey everybody, MS Farzan here, and in this video we're going to take a look at how to set up an integrated development environment, or an IDE. An integrated development environment is something that most all programmers have in one shape or form, and what I'm going to cover today may not be specific exactly to your experience as a developer, but it will give you some of the ideas of the types of things that you'll need to have a successful integrated development environment for yourself. And I'll cover the basics of what makes up an integrated development environment, and we'll be using JavaScript integrated development environment, and it's not the only one out there or the only way to do things, but it should show you some of the components that you'll need to get your development environment up and running. If you're working with a game engine, for example, which we'll talk about later, you might already have everything that you need to get your integrated development environment up and running. But if you're doing things at a more piecemeal level, like what I'm going to show you in this video, you might have to cobble it together yourself. The first question you might have if you're a new developer, or if you're coming from internet tutorials which allow you to code in the browser in a console without having to set anything up yourself, is what is an integrated development environment? And the simplest answer to that question is everything you need to be able to create your programs or create your code and then deploy them onto the web or into an executable, or basically everything you need to do to get your job done. That's going to differ based on the types of projects that you're making, as well as the types of languages that you're using for your development. But there are some things that are in common that you'll probably need to know anyway if you're working on your projects in a specific language. So I like to think of them as 4 things that you'll need to get an integrated development environment up and running. Specifically, if you're using something like Create React App, like if you're making apps with React, or if you're working in JavaScript, but it could also be applicable if you're working in Python and you're doing data science or data analysis, or perhaps you're working in C#, or in pretty much any other language. You'll need at least 2 or 3 of these 4 things. And I'm going to talk about each one of them in turn. These 4 things are a code editor, a command line interface, some sort of version control, and also a package manager. I'm going to talk about each one of these in turn. I'm going to start actually just by showing you a few things that I already have installed on my PC, and I'm working on a Windows PC, so if you're working on a Mac or Linux, this might be a little bit different for you, but by and large, a lot of the things will be the same. The first thing that I'm going to show you what I have running is I've downloaded Node for Windows. You can also download it for other operating systems, but Node is essentially it's based on JavaScript, and it's a backend framework that allows you to do stuff that you wouldn't ordinarily be able to do with JavaScript. And we'll talk about what specifically I'm using it for. All you got to do is download it and install it, and it'll be working for you. And I also have downloaded Git for Windows. I'm sure you've heard of GitHub. It's a type of version control. And I've specifically downloaded the Windows version because it has a different version for Windows than it does for Mac. So you'll want to download and install these separately before you get to the nit and grit of what we're going to talk about today. The first thing that I'm going to show you is a code editor. And a code editor you've probably heard of, someone's probably told you that you need to get a code editor if you're coming from, like I mentioned before, an internet tutorial where you can do all of your coding in the browser and you don't have to set anything up yourself. You're going to need a code editor of some sort which allows you to do all of your coding, and ordinarily it'll allow you, as you can see on the left side of the screen, it'll allow you to access the file system so you can make different files, you can put them in different folders, you can move them around and do everything that you'd ordinarily do with like your System Explorer, for example. And then it allows you to write your code in the code editor, and perhaps it has different tabs like this where you can keep track of different files that you're working on. And the code editor that you choose, most of them are going to have pretty much the same functionality. I'll talk about a couple of them here, and I'm using a code editor which is called Atom. Atom is a free and open source code editor that is super easy to use. It's very lightweight. It has some different integrations and functionalities that might be helpful for you based on what kind of development that you're doing. But a code editor is is, I don't want to call it a glorified version of Notepad because it does so much more than Notepad will do. But like if you were thinking, okay, I'm going to do all of my coding in Notepad or Microsoft Word or something, you probably won't be very happy with that experience. A code editor has stuff like color coding, so you know it will separate your classes from your variables, from other variables in your code base. From functions, from strings, and it will manage a lot of the stuff for you so that you can easily parse it with your eyes while you're like looking through a document or looking through a piece of code for, let's say, a specific variable. A lot of the code editors also have different integrations, like we'll get to GitHub later, but if you don't want to deal with GitHub outside of your code editor, you might be able to just do it right then and there through using the code editor itself with an integration. And it, in general, is just going to make your coding life easier on you. And it is an integral part of your integrated development environment. Some code editors, such as Visual Studio, also have a compiler. So if you're working with a language that needs to be compiled, such as C#, then that sometimes comes built in with the code editor. Like I mentioned, I'm using Atom, which is I find to be great and lightweight and free. If you're willing to go the subscription route, you can use a very popular code editor called Sublime that will do everything that you need and probably more, and you'll pay a subscription fee for that. There's also Visual Studio Code or Visual Studio. Those are both put out by Microsoft, and they will. I find Visual Studio to be super useful and very has a lot of integrations. Definitely, if you're working in a language like C#, you'll feel really well at home there. But a lot of these code editors allow you to use any language, and it really comes down to personal preference, unless you're doing something very specific that requires a specific code editor. And my thinking is that if that's the case, you'll already know about them and you're probably already working in them. The second thing we're going to talk about is a command line interface. The command line is, it takes many different forms. It could be called a terminal or bash or something else, depending on what operating system you're working with or what specific command line interface you're using. Here, because I've installed GitHub for Windows, I'm just using git bash, which comes that comes bundled with GitHub for Windows. As you can see, it's just text in a very plain format, and at its heart, what it allows you to do is access the file system on your machine and chain commands together to do different things that you might need to do for your development process. If this is a new concept for you, it can be kind of intimidating because you're doing everything with plain text and you're not able to like drag and drop files, which you might be used to. But it actually speeds up your production process because and your development process, because you're able to, as I mentioned, chain commands together and do a lot of things that are that may seem may make you scratch your head at first as to why you have to do them that way. But once you learn the process of using the command line interface, you will become much more faster in your development process. And you'll do things like, let's say I'm in my root directory now. I'm going to go into my coding directory because that's where I keep my coding stuff. And I will make a directory called new directory. And I'm not intending for you to learn exactly how to use the command line interface right now. You should probably look at a different tutorial for that, but just giving you an overview of how it fits into your integrated development environment. I've made this new directory and I want to see what's in the directory. Well, there's a lot of stuff in my coding directory, but if I navigate to my new directory, I can say, okay, what's in here? Well, there's nothing. I didn't make anything in there. And then let's say I want to get out of it. I go back to my root directory and I want to say, oh, you know what? I actually do want to make a change to that directory. And I go coding/new dir, and I go right there. So I don't have to click around with the mouse, for example. That's like the most basic stuff that you can do with a command line interface. There's so many more commands and so much. There's a whole world of wonder out there for you. And we'll come back to this when we're talking about GitHub, which is right now. After you have a working knowledge of the command line interface, here we're using git bash, you'll also want to encounter what's called version control or a version control system. Version control is a fancy way of saying that in the development process, there are a lot of different versions of the program or the game or the website or whatever project you're making. There are a lot of different versions, a lot of different steps to get it to its final state, the one that you're going to ship. And perhaps if you're shipping something like a game, there might be other states of that game after you've already shipped that game. And as developers, we need a way to manage all of those different versions of that program or of that project, particularly if we're collaborating with other developers that might be working on the same or other parts of that project. Let me give you an example. Let's say I'm working on a game and the basic system is just working, and I want to keep that system as it is. While I work on another part of the game that I don't want it to break the whole game. I just want to work on, let's say, the multiplayer part of the game, and the single player part is super stable. That means I'll have a super stable single thread of the game that is like my main game, and then I want to branch off this one little piece of the game, the multiplayer part of the game, and work on that and iterate upon it without touching the single player part of the game. I can perfect that multiplayer part of the game and then merge it with the single player game once I'm happy that everything's working. And then my project is happy, I'm happy, and whoever I'm collaborating with is also happy. And that is the essence of version control. There are a lot of different use case scenarios, like maybe I'm working with different people on different areas of the code, and I want to be able to collaborate without making things messy. Or let's say I want to keep a track record of different states of the game so I can roll back to a previous version if I break everything. So there are a lot of different reasons to have version control. And if you are working by yourself on a small project, you might not have the need for it, but you might still want to learn about what it is, and in case you do start collaborating. And at the very least, it's a really great way to keep a backup of your information on the cloud, or what's called a remote repository. Because I'm using git bash as my command line interface, I don't have to open a new program or something for it. I'll just show you an example where I'll go back. Let's see, the game that we saw where I'm using Atom for. This is a card game that I'm using in a framework that we'll talk about in a minute called Phaser. Phaser.io is a JavaScript framework for making 2D games. You can see I have all this stuff in my file system, and all these different files, and basically there are a lot of JavaScript classes that I'm importing into my main files, and going about my code. Well, all of this exists in a directory on my file system, which is actually Hacker Battles build. So I'll go into my coding directory, and then I'll go to the Hacker Battles build directory. And if I type in ls, which is the command in git bash to see what's going on in that directory, I'll see all of these different files and folders, which is the same as what's going on in this folder here. You can see my app.js, my package JSON, and everything here is the same. And then when perhaps I'll do another tutorial on GitHub itself. And GitHub, I should mention also, is not the only version control system. There are many others out there. GitHub just happens to be a very popular one and essentially an industry gold standard for version control. I can just type git status, for example, and it essentially what's happening right now is it's taking a look at my machine and saying, this is everything that is on the machine in this folder, that is what's called a local repository. And it is checking all of those files and everything that's in those files, like all of my code here, and saying, is this the same to the origin, which is on a cloud somewhere on GitHub, is called a remote repository, and it's saying like, are these two things the same? And now after I've checked the status of the thing of these things, it says your branch is up to date with the origin, and I'm on a branch called sockets, nothing to commit, working to reclaim. This just means that the changes I've made have been merged with the master repository, which is online on GitHub, and there's nothing to do here. If I make some changes here, it would throw me an error and say like, hey, this stuff's different. You better decide what to do with it. And that goes a little bit more into the depth of how to use the version control. You'll have to do something called committing, and then you push it to the remote repository, and it's a whole thing that you'll have to learn. But it suffice it to say that the reason why I'm doing this is not only as a backup, so I can back up my work that's here on my local repository or on my PC, but also I can keep track of the work that I'm doing while I'm pushing it to this remote server or this remote backup. And if I have other collaborators working on the same project, we can work on the same things or on different things and keep track of it through GitHub. And if one of us makes a mistake, or if one of us wants to branch off and work on a different feature without touching the main code base, I can do that using GitHub, and that's why it's so important. Finally, the fourth thing that you'll need for your integrated development environment is a package manager. Not every developer needs a package manager, and depending on what you're trying to do, and like I said, if you're using a game engine, your package manager might be already integrated with everything else that the engine offers to you. But they're good to know about anyway. The one that I'm using is called Node Package Manager, or NPM. It comes bundled with Node.js, so if you have installed it, it'll be right there waiting for you. There are a lot of other package managers. For example, Conda is a really popular one. So your mileage may vary with the one that you use, and there might be one that's better for your type of project. NPM is just fine, particularly if you're doing anything in JavaScript. It's almost assumed that you're using NPM. And a package manager essentially downloads and sometimes runs the files and the dependencies that you'll need for the projects that you're working on. And I'll give you a couple of examples here. First, if I go to create React app, which does what you think it does, it helps you to create a React app. It has some pretty simple, straightforward instructions for how to get started with create React app. Now, you might be thinking, well, I'm used to downloading stuff like by right-clicking it and clicking save as, or pressing a button, or downloading some other sort of software that will do it for me. NPX or NPM does this for you, and I'll show you an example of how it works. So if I look at create React app, what it wants me to do, and I'm just going to make this easier on ourselves to get me out of this directory and back into my new directory that we made earlier using the command line interface. Is this the one? Yes, we're in the new directory. So I'm going to just follow these instructions, which are super simple. And remember, you can chain commands in the command line interface, but we'll do things one at a time here. And we'll say npx create React app my app, as it says. And what this is going to do is, of course, you have to be, this should go without saying, but you have to be connected to the internet so that it can download the stuff that it needs. And then npm it's handling all of the installation of the packages that I need for creating a React app through create React app. And I don't have to do a thing. It's pretty cool. While it's doing that, I'll show you another framework. This is called Phaser, as we mentioned, a 2D game framework in JavaScript, and it has a very similar install process. You just go to your command line interface, and this is after you've installed Node, and you type in npm install Phaser at 3.20.1, and then it'll not only install Phaser, but also the dependencies that Phaser has. Like I think Phaser uses Babel, which is required for Phaser to work properly. What I highly recommend doing, if you're not doing this already, is just like click around these tutorials, figure out why you're doing the stuff that you're doing. Maybe even go to the you can go to the GitHub page, for example, for Phaser. Usually there's a README of some type that explains what's going on with Phaser and how to install it and what are the things you need to know. So we already looks like you don't even need those numbers, the version numbers. You can just say npm install Phaser and it will install all the dependencies for you and everything you need to get up and running with Phaser if you want to make 2D games, for example. But if we go back to our command line interface and look at what npm has done for us, it's installed create React app, and it says it both on the GitHub page for create React app and also in the command line interface. It says npm start starts the development server, npm run build bundles the app into static files for production, and you can test and etc. These are fancy ways of saying that that when you go to my app, which is cd my-app, that's where it installed everything, and then we say npm start, Node Package Manager is going to start a development server for us so that we don't have to do that. It's automatically going to open up a web page where using the local host with a port of 3000, and it's loaded this very basic web page here that has a hyperlink to learn React, and it has an image and this text. So if this was my app and that's all I wanted to do with it, I could use npm run build, and it'll create an optimized build for me to deploy for web. But before we get ahead of ourselves, let's just check out and see what npm has done for us, which will give us a pretty good working view of what our integrated development environment is with all of these four aspects. We have the code editor, we have the command line interface, we have a version control system using GitHub, and we also have this package manager that is running a server for us. And so if I go back to my code editor, which is Atom, right now I'm in the Hacker Battles build folder, and I want to switch folder, so I'm going to go to open folder, and then remember that was in the coding directory and in our new directory, and I'm just going to open this whole folder as like a project folder essentially in Atom. And this opens the new directory that has my app in it, which was just created for us by npm. And you'll notice that there's not much going on in the root directory of my app. I have to go into the public folder, and I'll look at the index.html, and you'll see, in looking at what create React app and through npm has done for us, it has created this whole directory of all this basically nested code, which it is now being served up into my web browser into this page. So if we kind of like look down at through the like peel the layers of the onion, we see that the div ID is root in the HTML of this index, which is being served here on the local host in the public folder. And then if we go to the source of these things, where things get really juicy, we look at the index.js, and we see that if you know anything about React, and if you don't, that's fine, I'll just explain it for you. Essentially, it is getting the element of root, the div ID, which is called root, and it is rendering this app. And the app is being imported from the same folder, and it's ./app. And the app class, essentially, if we look at it, it's we get all the way down to the center of the onion, and this is what's happening here. The app is essentially creating what you see here on this page. It's got the image that we saw. It has the hyperlink to reactjs.org, and it's got this little text that says learn React, just like this here. I think that's probably a little bit more than you need to know about React if you're not going to be doing any work in React. But the point is that npm Node Package Manager has created this whole file system for me and all of these different nested files, so that I can just get up and running with React without having to do all of this myself. If I'm a React developer, I probably already know everything that's going on here, and I can just start coding. And what I'm doing here is I'm using my code editor to actually write the code. I am using the command line interface to run commands such as npm start, and when I want to build something, I will use npm run build for deployment to web. I am accessing the file system using the command line interface, and all of this has been done by using the package manager, which in this case I'm using npm, but you could use something else. And on a word, let's say like a word on the version control, usually what I'll do, I'll open another window of git bash and probably use that for my version control. But in this case, I'll just stop the server and I'll say like git commit, and then I'll add a message and I'll say like, hi, first commit. And nothing's going to happen here because I don't have haven't actually done anything. And then I'll push it to the repository and the remote repository, and you'll learn how to do that if you check out some tutorials about GitHub or version control, whatever type of version control system you're using. But that's my general process. I have my code editor. I have used my package manager. I know I'm going out of order here, but I've used my package manager to install the packages and dependencies that I need, and I also use it to run my server and to create a final build. I am using the command line interface to do all of my work that is not the actual coding bit, coding part of it. And I am using version control to back up my work and also to collaborate with others and make changes to different features in my code base without touching the main source code. I said at the beginning of the video that this might be different for you. These 4 things, you might be using one of these things. You might be using 4 things plus more. You might be using none of these things. But they cover the general aspects of an integrated development environment that most developers need. If you're using a full suite of tools, for example, like you're using Unity to make 2D or 3D games, Unity usually comes with Visual Studio, so you won't have to install a code editor. It has it doesn't need a package manager. It just downloads everything that you need from right within the interface that it offers you. You can use GitHub separately from Unity, but I think Unity already has like a GitHub integration, or you can install it, so you don't really need a command line interface for anything. So you might not need any of these things, but behind the scenes, you're still kind of doing all of these things in your integrated development environment, and it really will depend on what language you're using, what kind of projects you're using. For example, in this case, I'm just using plain old JavaScript in a code editor, and I don't have to compile it. But if you're using another language like C# we mentioned, or C++, you will need a compiler that actually like compiles your code and makes an executable for you. So that's something to look out for. I hope this video has been helpful for you and interesting. And if it has been, please feel free to like my video and subscribe to my channel and check out my books, and we'll have more for you soon.